Hey guys, so you may have noticed this already, but somewhere around July 23rd, 2024, College Board updated the math portions of the Bluebook SAT practice test number 1, number 2, and number 3. 6 questions were replaced with brand new questions, 2 from each exam. If you're coming here for my longer test review videos, you can find the exact questions you need using the chapters in the description below. Let's get started. Bluebook practice test number 1, module 2B, question 8. Okay guys, so for this one, if you have not already watched my 3 shorts on exponentials plus time, you definitely want to check that out. It's part 3 series in the shorts tab. So the formula I'm going to use is covered in those videos. Y equals A times B. Let me move this down so you can see. Y equals A times B to the T over N, or how about since they use X in this problem, I'll say X over N. So A is the initial Y value, the Y-intercept, B is the multiplier, and N is the interval. The interval tells you how often that multiplier gets fully applied. So you see all this stuff where it says, for each increase in the value of X by C, where C is a positive constant, the value of f of X increases by a factor of 27. So the multiplier is 27, and then N, the interval, how often that happens, is going to be C. So we really, to answer the question, we really want to figure out this guy. And because this is a factor of 27, by the way, I should point out, it says equivalent forms, so all these answer choices are the same, so it doesn't matter which one you use. So I'm already gravitating towards the one with a 27 in the answer, that's option D, just to kind of work with to figure out the answer. I'm also kind of gravitating towards this 3 cubed because that 3 cubed is just 27. You can use either of those. I'm going to use D just for the sake of teaching. So we want to make it look like that. Well, 27 to the 1/3 X to the 1/2. When you raise a power to a power, we just multiply the powers together. And like 1/3 X times 1/2, that is equal to 1/6 X, or X over 6. So hopefully you guys are seeing, oh, we got a multiplier of 27. That's what the question was talking about. And we've got an interval of 6. So we just learned something very important. C is equal to 6. That's just what the question named the interval. When I teach, I call it N. Okay, so it wants us to see which equation has 1 over C on display. Well, 1 over C is 1 over 6. So now we're just looking at all of these answer choices to see which one has a 1/6 in it. And sure enough, the only one that has a 1/6 on display is answer choice B. And that is our answer. Let's jump to Desmos. Okay guys, so I'm going to just pick whatever answer choice I want. Remember, they're all equivalent. Let's just pretend we're starting over. So I'm going to use answer choice A just for the sake of variety. So let's do f of X equals 48, 3 to the 1/2 X. Okay, looks good. And I'm going to try to figure out what X changes by when I apply a multiplier of 27. So why don't we just pick 2 random numbers? I'm going to do 2 that are in that range. So like, see how the range is 0 to infinity. So why don't I do 2, and then 2 times 27 is 54. So why don't we do Y equals 2, and Y equals 54. And you will see we went from 0.214 to negative 5.786. That distance that we traveled in the X direction is 0.214 minus negative 5.786. That is 6. So we moved 6 to the right to apply a multiplier of 27. So C equals 6. And that means 1 over C is 1/6. And you can now look at the answer choices and just scan with your eyes. Do you see a 1/6 in any of these answer choices? The only answer choice that has a 1/6 in it is B. Great, let's keep going. Bluebook practice test number 1, module 2B, question number 16. Okay guys, if you've been watching my channel, this should look really familiar. I actually have an entire video dedicated to just this question. It's Desmos lesson number 19. And this is not the first time we've covered this. It comes up in the practice test in my Blue playlist as well. So let's jump to Desmos. Why don't we do that way first, because that's what I would do on the test day. All right, so let's see here. First, I'm going to type in 2x plus 3y equals 7. Then I'm going to type in 10x plus 15y equals 35. And you see they're the same line, so it kind of doesn't matter that there's 2 of them. It's just one line. Now I'm going to type in the answer choices. Let me first make a slider for r. When I do r equals 1, don't care about that circle. We can just leave that like that. And I'll type in a. So r over 5 plus 7, comma, negative r over 5 plus 35. And I'm going to label it with option A. And give me 1 second while I type the rest of these in, just like that. Okay, so all I did was type all those in and pick the colors, just like I was doing earlier. And I'm looking for a for each real number r, so I want the point to always be on the line. So I'm going to come over here and I'm going to move this slider around, and hopefully you can kind of tell C, D, and A are all not on the line always, but B, the orange one, is always on the line. So that is the answer. Now, did it take me about a minute to type that in? Sure, but am I going to have a 100% chance of getting it right? Yeah. So is it really that much of a waste of time if this is one of the harder questions on the test and doing it by hand isn't that much faster anyway? I don't know. I highly recommend you do it this way. Go check out Desmos number 19 if you want to practice this more. All right. So let's talk about how to do it by hand. Let's come back over here. I would just go down all the answer choices and essentially guess and check. That's kind of the only way to do it. And I'll use the smaller line, and let's just, with the benefit of the hindsight, just do B in the interest of time. So 2x is negative 3r over 2 plus 7 halves plus 3y is r equals 7. And 2 over 2, okay, so I get negative 3r. 2 times 7 halves is 7. 3 times r is 3r. And you see those two guys go away. And we get 7 equals 7. So that means it has infinitely many solutions. It is always on the line. If you did that for A, C, and D, you would find that you would maybe get like 5 equals 0 or R equals 8, something like that. Something that's not infinitely many solutions, not an identity. But yeah, I don't know. Even though it might have been just a hair slower, I'd totally rather just have a 100% chance of getting it right and type it in. Great, let's keep going. Bluebook practice test number 2, module 2B, question number 6. Okay, guys, I do have a video designated for this. It's my short on completing the square. I'm going to go over how to do it by hand first. Definitely go watch that short. I think I'll put some cards in this video, so hopefully there'll be a card for that one. But definitely go check that out if you haven't seen it already. I'm just going to assume you've already watched that. All right, so first thing I notice is there's 8s in front of these x squareds and y squareds. We don't want that, so we're going to divide the whole thing by 8. So if you go left to right and divide the whole thing by 8, we should get x squared plus 14px. Going to leave some space so I can complete the square. plus y squared 64, so that's minus 8py, leave some space so I can complete the square, equals negative 56p squared. All right, now I'm going to complete the square. To complete the square, we add b over 2 squared. So I'm looking here for b, and I'm looking here for b. Doesn't matter if it's positive or negative. When we square a negative number, it's always going to be positive. This is all covered in the video. All right, so 14p divided by 2 is 7p. 7p squared is, in parentheses squared, is 49p squared. I'm going to add that to both sides. And then y squared minus 8p. Okay, negative 8p divided by 2 is negative 4p. Negative 4p, in parentheses squared, is 16p squared. So we're going to add 16p squared there, and then to the other side as well. Okay, and now we can start factoring this guy. So if you take the square root of the third term, providing you did it right, the square root of 49p squared is 7p. So this is just x plus 7p, positive because it's positive 14p. And then y, 16p squared, that's 4p square root. But it's negative because you see we have a negative 8p. So this is going to be minus 4p squared. And then if you do negative 56 plus 49 plus 16, you should get 9. So this is 9p squared. Okay, that's the equation of the circle. Now we're going to use what I talked about in my other circle short, how to find the center and the radius. So the center, we change the sign of these two guys. And then the radius, we take the square root of this guy on the right. So the center is negative 7p, comma, change the sign, positive 4p. And then the radius, the square root of 9p squared, is 3p. Now the question says the radius is np, so I'm going to write np equals 3p, and if we divide both sides by p, we get n equals 3. And that is the answer. Great, let's go do it on Desmos. Okay, so it says p is a positive constant, so I'm just going to pick a random positive number. There's already a bunch of 3's, right? So why don't I make like p equal 4 or something? And I'm just going to type in the equation from the very beginning. 8x squared plus 112px plus 8y squared minus 64py equals negative 448p squared. And you could do this with any positive value for p. Probably I would do like 2, 3, 4, or 5. Okay. I covered this in a bunch of my Desmos videos, but especially the equation of a circle. I'm going to treat it like a compass, and I'm going to type in north is negative 28, 28. Label that, make sure I did it right. South equals negative 28, 4. Label that. Now to find the radius, we're going to do distance n comma s over 2. And now to find the center, we're going to do midpoint n comma s. Then we'll label that. And the radius is 12. Okay, so they told us that the radius of the circle is np, so r equals np. So that means that n is equal to r over p. And we get n equals 3, just like when we did it by hand. And if you went through and followed that process for like any value for p, you should get the same answer. This one, I think that algebra with all the P's and everything might have confused a lot of people. I probably would have just typed this one in on Desmos and just started doing everything we did in the Desmos playlist. Great, let's keep going. Bluebook practice test number 2, module 2B, question number 17. Okay, guys, so for this one, we want to do y equals f of x plus 9. You don't really need to understand function translations to do this one, but I do have a video on that, Ottocento number 5 on function translations. Definitely go check that out. Plus 9 on the outside is a shift of 9 up. Regardless, you'll see when we make the picture on Desmos. This entire thing is f of x, so I'm going to just put a little plus 9 just to save myself some writing. I'm going to call this new function g of x as well. So g of x equals 6d 20x plus 21. 17 plus 9 is 26. And I'm going to now distribute that guy on the right-hand side. And as a matter of fact, while I'm doing that, we want to find the x-intercept. So when you want to find a y-intercept, you make x 0. When you want to find an x-intercept, you make y equal to 0. So we're going to replace y, or g of x, with 0. So 0 equals, and I'm going to distribute as well. So 120 dx, what's 21 times 60? That's 126d plus 26. And hopefully you guys can see, let me help you visualize. We want to get x by itself. So, first thing we're going to do, reverse order of operations. We want to move the coefficient like last. So we're going to get these guys out of here, and to do that, we're going to subtract both of them from both sides. So we get negative 126d minus 26 equals 120 dx, and you'll see once again, just to make it easier for me to visualize what I'm going to do, I'm going to put a box around it. And now we're going to, the opposite of multiplication is division, so we're going to divide both sides by 120d. And I get x equals negative 126d minus 26 over 120d. That can certainly be simplified, but for whatever reason, they just leave it like that, so I believe it's A. This one can also be entirely done on Desmos, so let's go do that. Okay, so I'm going to make d a constant. It doesn't give me any restrictions, so when I call it 5, I'm going to type in f of x equals 6d 20x plus 21, 17, and then g of x, or you could just type in what the question says, y equals f of x plus 9. Don't care about the blue one. Okay, so the x-intercept, hold on. I did not do that right. Okay, that looks good. So the x-intercept is negative 1.093. Using d equals 5, you can use whatever you want. And now I'm just going to start typing in the answer choices. So, give me a second. Okay, guys, so as you can see, the only answer choice that matches the x-intercept we came up with using d equals 5 is answer choice A. You see, it's just different because of the Desmos rounds at the 3 to 3 decimal places. I don't really understand what the point of this was. I thought the point of this update was to make it so that people couldn't do questions on Desmos, but apparently that's not the case. Was that slower than what we did on the board by hand? Maybe, but I don't know. You're way less likely to make a mistake. Do it on Desmos probably, so I don't know. Pros and cons, as always. Great, let's keep going. Bluebook practice test number 3, module 2B, question number 8. Okay, guys, so first thing I'm going to do is label these things on the picture. You're going to have to, on test, I actually copy this down, right? So let's put AD is 121 over 3. And then AB is 11 root 130 over 3. Now, there's a bunch of ways to do this problem. For me personally, I think it's going to be easier if I can find this side. And to do that, we can use the Pythagorean theorem, which is on the reference sheet. So a squared plus b squared equals c squared. So that's 121 over 3 in parentheses squared plus bd squared equals 11 root 130 over 3 squared. And if you do that, you should get 14641 over 9. You just do that on a calculator. Equals, and then the right one on a calculator, I think, is 157. We're going to verify this at the end. There's just no point in jumping to the calculator just for 2 seconds. And if we subtract this guy over to this side, you could do that on a calculator too. We should get BD squared equals 121. So BD is equal to 11. So I'm going to put that on the picture, 11. Now, we could have done this from the beginning, but there's something called the altitude on hypotenuse theorem. And I'm going to be honest, I'm not that good at this, and I don't have a video on it. So what I'm going to do is in the comments, I'm going to link to like 1 or 2 videos that goes over it in more detail. There's a bunch of ways to look at it. One really handy formula that I thought for this one was the height squared is equal to the left segment times the right segment. That's just my own notation. I just came up with that. So this one squared is equal to the left one times the right one. You could make a picture, break it up, and use similar triangles, but like, man, if you just know this altitude on hypotenuse theorem, it becomes a lot easier. So I'm probably going to start doing that from now on, since this isn't the first time they've asked a question like this, right? It's kind of annoying. Anyway, so yellow squared, so 11 squared equals the left side of that bottom of that base, so 121 over 3. And then DC is what we want to find, so why don't we call that X? So X, so I get 121 equals 120 over 3. If you divide both sides by 121 over 3, you should get X equals 3. And that is the answer. Like I said, I'll link a video in the comments about altitude and hypotenuse theorem. Give me a second while I just show you something on Desmos really quick. Lots of people mess this up. I just know from my own experience tutoring that lots of people mess this up when they go to type in something messy into a square. So I'm just going to do this just kind of as proof to hopefully save me some comments to answer. So you see 14641 over 9. And then 11 SQRT is square root, if you didn't know. And then if I come down here, $121, and then we take the square root of that in the algebra, and we get 11. This is definitely, I think, the hardest question out of all the ones they added. Great, let's keep going. Bluebook SAT practice test number 3, module 2B, question number 15. Okay, guys, first thing we're going to do is use the zero product property. I go over that in my Ottocento video on factoring. So definitely check that out if you haven't already. So all of these factors, either at least one of them has to equal 0 for the whole thing to equal 0. So I'm just going to kind of circle them, and then we'll just kind of write them down on the page here. So 3x plus p equals 0. I'm going to solve for x. So 3x equals, subtract p from both sides, negative p. Then divide both sides by 3. So x equals negative p over 3. That's the solution to that first one. The second one, 5x squared minus 45 equals 0. I notice we have a common factor of 5. So x squared minus 9. Now I'm going to use difference of two squares, which is also covered in the factoring video. Please go watch that if none of this is making any sense. So this would be x plus 3, x minus 3. And now we're going to do the zero product property on this. So you see these two, if I set each of these equal to 0, I get x equals negative 3 and x equals 3. You could have also done something else, but I don't want to give it away. Let's go over that in a second. So 2x squared minus 16x plus 6p equals 0. Now, this has a common factor. You could pull out the common factor of 2, but then you'll see that it's not factorable any further without knowing what p is. So what we're going to do is we're going to use Vietta's formula for the sum, which I go over in my Ottocento on basic quadratic. So please, please, please go watch that. I swear I'm not just pulling these out of a hat. All right, so we can find the sum of the solutions just for this factor by doing sum equals negative b over a. That's the formula you got to know. So b is negative 16 and a is 2. So we're going to do sum equals negative 16 over 2. So the sum is equal to 8. So now it says the sum of the solutions to the entire equation is 20 over 3. So see, even though we didn't know those two solutions for the 2x squared minus 16x, we know what their sum are, and that's all we care about, right? We just care about what their sum is. We don't care what they are. All right, anyway. So we're going to add all these up. Negative p over 3 plus negative 3 plus 3 plus 8 equals the sum they told us, 20 over 3. And let's see what that is. So the negative 3's go away. So again, negative p over 3 plus 8 equals 20/3. You could clear the denominator, but this is such a small amount of work, it doesn't matter. So subtract 8 from both sides. 20 over 3 minus 8 is negative 4/3. So we get negative p over 3 equals negative 4/3. If I multiply both sides by negative 3, I get p equals positive 4. I don't know how helpful Desmos would have been to get the answer, but we can do it to verify our answer for sure. And it'll hopefully make more sense what's going on. So why don't we do that? Okay, so just trust me, guys. This is going to be difficult for us to click on. So I'm going to break it up into a system, just like Desmos lesson number 1. Okay, does that look right? I hope so. All right, so looks pretty good. And then I made y equals 0, and we're going to do p equals, what did we say, 4? All right, so we've got a bunch of solutions. The only messy one in all these is negative 1.333. That's negative 4/3. So we're going to just go from left to right. Negative 3 plus negative 4/3, that's this one, plus a 0, plus, sorry, not 0, that's not a solution, there's no red there. 2, 3, and 6. Okay, 2 plus 3 plus 6. And you see if we add all those up, we get 20 over 3, which is what the question said we should get. So we did a good job. So you really got to know the zero product property. You really got to know how to factor. And you really got to know the sum and product solutions formula. So if you haven't watched my Ottocento on factoring or Ottocento on basic quadratics, please go check those out. They will help you a lot. Okay, that completes the lesson. Please like and subscribe for more digital SAT math content. And if you're interested in my tutoring services, the link to my website will be in the description. I tutor SAT math and all math subjects from about 7th grade to AP/early college level. Thanks for stopping by, and good luck studying.